Homework question 11.5 asks us to consider the molecule shown below and the pair of energy diagrams for the next set of questions. It helps me when I do hybridization to make a nice little chart. On the left side, we have the number of effective pairs, and that refers to the number of lone pairs plus number of atoms bonded. And on the right, corresponding to that number of effective pairs, we have the hybridization. The most relevant sets we have are 2 effective pairs, 3 effective pairs, and 4 effective pairs. If something has 2 effective pairs, then it'll be sp hybridized. If it has 3 effective pairs, then it will be sp2 hybridized. And if it has 4 effective pairs, then it will be sp3 hybridized. Organic molecules tend to leave out hydrogens that are bound to carbons. They're implied, and so it's our job to know that they're there. It personally helps me to draw them in just to see them sometimes. Carbon needs 8 valence electrons, which corresponds to 4 bonds. Carbon A is only bonded to carbon B, so it should have 3 hydrogens. Carbon B is bonded twice to carbon C, so that counts for 2 bonds, and bonded once to carbon H, and then also another time to carbon A. That's 4 bonds, so there's no hydrogens on carbon B. In this way, we can fill in all the hydrogens on this compound, not putting any on nitrogen because hydrogens aren't implied on anything besides carbon. So to organize ourselves a bit, I want to make a table. In this left column, it will be whatever carbon we're talking about. The middle column will be number of effective pairs. And the right column will be the hybridization. Carbon A has no lone pairs, but it is bonded to 4 different hydrogens. So it has 4 effective pairs. 4 effective pairs corresponds to an sp3 hybridization. B has no lone pairs again, but it is bound to 3 different atoms. That is an sp2 hybridization. Carbon C, again, no lone pairs, but it's bound to carbon D, carbon B, and a hydrogen. That's 3 different atoms, and therefore that's an sp2 hybridization. Carbon D has no lone pairs. It's bound to a carbon, a nitrogen, and a hydrogen. So that's 3 different atoms. That's 3 effective pairs, and therefore an sp2 hybridization. Nitrogen, in the E position, has 1 lone pair, and then it's bound to a carbon, carbon D, and carbon F. So that's 2 different atoms. That is 3 effective pairs, and therefore an sp2 hybridization. Carbon F has 0 lone pairs. It's bound to 3 different atoms, and therefore has 3 effective pairs and an sp2 hybridization. Carbon G has 0 lone pairs and is bound to 4 different atoms, so that's an sp3 hybridization. And lastly, carbon H has 0 lone pairs and is bound to 3 different atoms, giving it 3 effective pairs and an sp2 hybridization. Number 1 asks us which of the atoms are sp3 hybridized, and if we look through our list, we see that carbon A is sp3 hybridized, as is carbon G. So we'll write A and G. The next statement asks which of the atoms are sp2 hybridized. And looking through our list, we see B, C, D, E, F, and H are all sp2 hybridized. The third statement asks which of the atoms are sp hybridized. That would refer to atoms with a number of effective pairs equal to 2. We didn't have any of those, and so we have none that are sp hybridized. So number 4 asks us which of the atoms is or are represented by the energy diagram on the left. So typically when these energy diagrams start out, we have 1 s orbital and 3 p orbitals. Here we can see that we have mixed 3 of these orbitals in total to all be the same energy, so that's these, and one of them has stayed the same energy that it started. So if we mix 1 s orbital and 2 p orbitals, what we end up getting out of that are sp2 orbitals, and what's remaining is a p orbital. So what we know from this energy diagram is that this atom is sp2 hybridized, and that it has 1, 2, 3, 4, 5 valence electrons. What has 5 valence electrons? Nitrogen. So what we want to look for in the structure right here is a nitrogen that is sp2 hybridized. Nitrogen with the letter E is in fact sp2 hybridized, and therefore the atom that is represented by this energy diagram is atom E. Looking at the energy diagram on the right, we see that we have 4 hybridized orbitals that are all the same energy. That indicates that we mixed all 4 of our orbitals together to hybridize them. So having 1 s orbital and 3 p orbitals means that these are sp3 hybridized. And we know its number of valence electrons, which is 4. What atom has 4 valence electrons? Carbon. So here we're looking for an sp3 carbon. And looking through our list, I guess this would be better to say atom instead of carbon since we have that nitrogen. We see that carbon A is sp3 hybridized, as is carbon G.